Dear students, today we are going to take two questions from ISI 23 paper. As you all might be knowing that ISI stands for Indian Statistical Institute. The first question states that consider a triangle with vertices 0, 0, 1, 2 and minus 4, 2. Now it is saying that let A be the area of the triangle and B be the circumcircle area, sorry, here it needs to be written that area, just a minute, area of the circumcircle, okay, of the triangle, then B upon A equals. This is a straightforward question and we will look at it. See, the vertices are given, and we need to, first of all, the key to this question you will clearly see just in few minutes, that if one coordinate is given as 0, 0, another one is 1, 2 and one is minus 4, 2. So if you will find the slopes of these two lines, these three lines, you will find that one of the angle of this triangle is 90 degree. So let us first of all find the slope, because anyway we need to find equations of one of the side and we will drop a perpendicular from the opposite side to measure the length of the altitude. So let us first of all find the slope of this line. It will be 2 upon 1 and this is equal to 2. This will be equal to 2 upon minus 4, that is equal to minus 1 upon 2. So see, it is evident that one is 2 and one is minus 1 upon 2. That means these two are perpendicular to each other. Okay, now the work is very easy, because first of all we need to find the area of the triangle. So what will be the area? 1 by 2 into base into height. This is the height, or these two pairs are base and height. So what will be the distance of this? The length of AB is, we can write it 1 by 2 into AB into AC. So the length of AB will be 1 by 2 into root 5 and AC will be 2 root 5. Okay. So the area A will come out to be 5 square units. Okay. Now it is also asking that B is the area of the circumcircle of the triangle. So how we will be finding the area of the circumcircle? For that we need to find the radius of the circumcircle. Okay. So what will be the radius here? Area of the circumcircle. We all know by the property of the circles that a diameter subtends an angle of 90 degree at the circumference of a circle. So if this is 90 degree, that means the BC should be the diameter of the circle. Okay, and obviously that circle would be the circumcircle, because it would be touching all the three vertices of the triangle. So if BC is a diameter, the theorem that I am using here is that if there a circle is given and if AB is a diameter, then if AB is a diameter, then if we draw a triangle like this on the circumference of the circle, then this particular angle, that means angle in a semicircle, will always be equal to the right angle. So this length AB will be the diameter, and similarly here if this is a right angle, that means BC will be the diameter. So we can find the radius. The radius will be equal to the midpoint of this particular line. So we can find the midpoint. The midpoint will be, or we can just find the distance and divide it by 2, that will be the radius. So R is equal to distance of this minus 4 minus 1, that means minus 5 square and plus 2 to 0, that is equal to 5 units. So the area will be equal to pi r square, or pi into, wait, this is not radius, this is diameter. Okay, this is D. So R will be equal to pi into pi r square, that means 5 upon 2 ka square. This is equal to 25 pi by 4 units. So what is this? This is B. Okay, this is B. Now we need to find the ratio of B upon A. So B is 25 pi by 4 and this is 5 B upon A. So this will be equal to 5 pi upon 4. This will be the answer. Okay. So yes, this was the second option, 5 pi by 4. So the main thing was to identify that this triangle is a right triangle, and once it is identified, then question is quite simple. Now coming to the next question. The next question is an interesting question. It is from complex numbers topic. See what it says, that summation k is equal to 0 to 202 minus 1 to the power k, 202 k and cos k pi by 3. Okay. So if I denote this sum by s, then we can conclude this. First of all, one thing needs to be noted here, that cos pi by 3 plus I sin pi by 3. I can write this and I can name this as t. Let t be a complex number denoted by this. And by de Moivre's theorem, we know that if I raise t to the power k, then this will be equal to cos of k pi upon 3 plus I sin k pi upon 3. And this particular term seems to be the real part of this thing, t to the power k. Okay. This particular term is nothing but real part of t to the power k. So for the whole expression, if just we intuitively see it, then it seems that there is somewhere involvement of the binomial theorem. Okay. Now if I have written this particular term, see, if I do expand this particular term and take its real part, then it is nothing but this particular series. If I do expand it using binomial theorem and I do take the real part of this, then it is nothing but this particular expression. How? We can write it like this: 1 plus minus 1 into e to the power I pi by 3 and 2 is not 2. So we can apply binomial theorem and we can get it like 2 not 2 C0. This is combination, the same symbol that is written here. So 2 not 2 C0 and 1 power 0 and minus 1 power 2 not 2 into e I pi by 3 to the power 2 not 2. Similarly, the next term will be 2 not 2 C1, 1 power 1 and minus 1 power 2 not 1 into e to the power I pi by 3 2 not 1. Okay. Similarly, the kth term can be written. Okay. The kth term can be written, and this will be, the kth term will come out to be 2 not 2 ck 1 power k minus 1 to the power 2 not 2 minus k and e to the power I pi by 3 2 not 2 minus k. Okay. So we can clearly see from this series that this particular term that we were required to find the value of that, it is nothing but the real part of this particular sequence. Okay. So I can write it here that this sequence S is nothing but the real part of 1 minus e to the power I pi by 3 2 not 2. Now but now see, it is not easy to find the real part of this particular series. Okay. So it would have been better if we could reduce it to a single quantity. So how we can reduce it to a single quantity? Let us see. that if any by any algebraic manipulations or anything can we reduce it. So, E I pi by 3, this can be written as cos pi by 3 plus I sin pi by 3. Okay. Now, 1 minus E I pi by 3, this can be written as 1 minus cos pi by 3 minus I sin pi by 3. Okay. So, this if I take out the value, then 1 minus cos pi by 3, that means cos 60 half, and sin pi by 3, that means root 3 by 2. So, this is equal to half minus I root 3 by 2, that is equal to conjugate of this particular thing, that means this is equal to e power minus I pi by 3, and this thing what I have done, 1 minus e raised to the power I pi by 3, that is equivalent to e raised to the power minus I pi by 3, and once this has been done, now the simplification is quite easy. So, we can substitute in this place this particular value e to the power minus I pi by 3. Okay. So, here we would be writing real part of e raised to the power minus I pi by 3 to the power 202. Now, by de Moivre's theorem, we can write it as e raised to the power minus I 202 pi by 3. So, the real part, we are just telling it that real part, that means it would be nothing but it would be equal to cos 202 pi by 3. So, this would be the answer. The value of that particular series would be cos 202 pi by 3. So, this was a good question. Both of these questions are from the ISI 2023 paper. So, if any of you are having any doubt, then please ask in the comment section, and if there are any suggestions, please also ask in the comment section. I hope that you might have enjoyed this video. Thank you.